Hi ladies. All right, so in this video we are going to look at solving quadratic equations, and we are going to use strategies of balancing to do so. After we solve, we're going to verify using our graphs and our abilities to graph using transformations. All right, so the whole idea is that I want to isolate x. So how am I going to do that? So the first thing I'm going to do is I'm going to begin my balancing process. I'm going to eliminate this minus 3 by adding 3 to both sides of my equation. I get 1/2 x minus 2 squared is equal to 2. Now, to eliminate this 1/2, I can either divide both sides by a half, but I personally rather multiply both sides by 2 to eliminate a fraction. So that eliminates. I now have x minus 2 squared is equal to 4. Now, to go and solve this equation, I'm going to use a square root function, but I need to be thoughtful about what I originally started with. My original equation is that some number minus 2 squared is equal to 4. If I put any number inside of this parentheses, whether it's positive or whether it's negative, when I square that value, I'm getting out a positive 4. So if this result was negative 2 and I squared it, I would get 4. And if this result was positive 2 and I squared it, I would get 4. That means I actually have two solutions to this equation. I have x minus 2 is equal to positive 2, or x minus 2 is equal to negative 2. And it's important, and you will see graphically, that you find both of those solutions. So x minus 2 equals 2, or x minus 2 could equal negative 2. Again, I'm going to balance, adding 2. I get x equals 4. I'm going to add 2. I get x equals 0. All right, so let's look at this graphically. This equation is really just a system of two functions, and I'm looking for the overlap, right? I'm essentially saying, when is this equation, like this expression, going to be equal to the value of negative 1? And I can see that graphically. So what I'm going to do is I'm going to pick apart my two functions. The first one is 1/2 x minus 2 squared minus 3. And then the other function is just equal to negative 1. All right, so let's go over here. So f of x is equal to 1/2 x minus 2 squared minus 3. That's the first function I'm going to graph. And then the other function I'm going to graph is g of x equals negative 1. So this begins at 2 and then moves down 3. It begins at 2 and then it's going to move down 3. Now, my steps for this function. Normally I go up 1 over 1, up 3 over 1, and then up by 5 over 1 if I can. Because this is multiplied by a half, my vertical step is now compressed by a factor of a half. So instead of moving up 1 over 1, I'm actually going to move up by a half over by 1. And then instead of moving up 3 over 1, half of 3 is 1.5. So I'm actually going to move up 1.5 over 1. The idea is that your vertical steps are now being compressed by a factor of a half. You know what? I'm going to write those up here. So normally I would move up 1 over 1. I'm now going to move up a half for, you know what? There's no space down here. Let me go over here. Normally I would move up 1 over 1, up by 1 over by 1. But now I'm moving up by a half over by 1. Similarly, normally I would move up by 3 over by 1. Now half of 3 is 1.5 for every 1. All right? And if you wanted to do the next round, it would be 5 over 1 times a half is now I'm moving up 2.5 for every 1. All right? So I did it on this side. I'm going to do the same thing on this side. And let's do up 2.5 over 1. Up 2.5 over 1, and then up 2.5 over 1. So here's my parabola. And then my other function is g of x equals -1. This is basically saying that all of the points that I'm graphing have a y value of -1. So here's a y value of -1, here's a y value of -1, here's a y value of -1. Any point that exists inside of this horizontal line is going to have a y value, an output value of -1. Now notice where these two functions intersect. At an x value of 0 and at an x value of 4, these two functions are overlapping. That means my solutions of 4 and 0 are indeed verified by my graph. All right, so that is how you solve a quadratic equation using a system and algebraic balancing.